In volume 23 of the Flynn Chem Topic Lab Manuals, The Chemistry of Foods, Irene Sessa of Flynn Scientific has developed a lab on the total acidity of fruit juices that I've taken a look at, and I like to downsize the labs a little bit. So what I'm going to show you is a very quick run through of a way to do Irene's lab on a little bit smaller scale. On the board here, I have the three principal acids you're going to find in essentially any fruit juice: citric, tartaric, malic. Sometimes you get a combination of those, sometimes primarily just one. I like to have my students, even if they're not using a juice that has a high amount of citric acid, I like to use either citric or tartaric. I'd like to use citric rather than the other two, just because they don't do a lot of 3-to-1 mole ratios otherwise. Here's the idea. Student is going to take a sample of juice, put some phenolphthalein in as an indicator, and titrate to a phenolphthalein endpoint. Problem is that whether it's orange juice, white grape juice, pineapple juice, grapefruit juice, whatever it is, that juice is going to have a little bit of a color. So you want to do kind of a dry run first, and I'm going to show that to, number one, get an idea what the endpoint's going to look like, and number two, to get a rough idea of how much of the sodium hydroxide titrant you're going to need to make the thing work. So I've got orange juice here. I would like to have pulp free. This isn't. So we'll see how it goes. What I'm going to do is put about 10 drops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, in pretty much any vessel you want. I have a large test tube here. It could be a small test tube. It could be a small beaker. Some vessel just to hold it. Remember, this is my rough titration. I'm going to put a couple of drops of phenolphthalein in. 1, 2. The third one didn't count. The third drop was silent. Mix it around. Remember, I said this is a rough titration. I've got some 10th molar sodium hydroxide. I'm using 10th molar. If I'm going to do the calculations the way they are in the PDF that you'll see accompanying this, I'm going to record the concentration in units of moles of sodium hydroxide per gram of solution, because my students are going to weigh the pipettes. This is a gravimetric rather than a volumetric titration. I got this number because when I did this with my classes at the end of the school year a few weeks ago, that was the concentration we had. I got that by making the solution and actually weighing what I had. Typically, you're going to be, to two significant figures, you'll always have 1.0 times 10 to the minus 4. Microtip pipette for this one, because after this first part, I'm going to want to be as precise as I can. What I'm going to do here, remember this is my rough titration, I'm going to add blocks of 5 drops. 1, 2, 3, 4, 5. Got a little bit of a rosy pink color, but it went away. Try 5 more. 2, 3, 4, 5. I'm at 10. 1, 2, 3, 4, 5. 15. 2, 3, 4, 5. 20. 1, 2, 3, 4, 5. 25. 30. Getting a little closer to the end point. 1, 2, 3, 4, 5. Was that 35? And I have my end point. So I know that 10 drops of this particular juice takes about 35 drops of sodium hydroxide. I'm going to use, for my careful titration, about 1 milliliter of the juice. Milliliter with this pipette is about 35 drops. So I expect to need, well, if 10 uses 35, let's say 30 would use a little over 100. Okay, so I know I can go pretty fast for the first 100 drops. This pipette is calibrated to 1 milliliter, so I'm going to run it down to that. One milliliter of juice. Now I know that I'll probably need to refill this, so I will. I have the concentration of the sodium hydroxide listed in moles of NaOH per gram of solution. I know I'm going to need something over 100 drops. This kind of pipette delivers about 50 drops to the milliliter. So I can pretty freely put in, after the phenolphthalein, a milliliter or so of the sodium hydroxide. Before I start adding the sodium hydroxide, I weigh that pipette. Now I'm getting pretty close. I've put about 1 milliliter in. So now I tell the students, start going pretty carefully. Anytime you see that same, in this case, kind of a rose color, shake it and either it goes away or you're done. Getting close. Kids get really disappointed when the color goes, oh man, I thought I had it. It's fooling me. Mr. L, it's messing with my head. Good. Something has to. Okay. Nice endpoint. Take this back, weigh it, take the difference in mass of this pipette, multiply it by the number of moles per gram of solution. I have the number of moles of citric acid, sodium hydroxide, 3-to-1 mole ratio between citric acid, and certainly with orange juice, citric acid is the one I want to use. Get the number of moles of citric acid in that 1 milliliter of juice that I used. The whole point was to make a smaller scale version of a really very nice lab that you'll find in the Flynn Chem Topic Manual. I like small scale. I like the speed and the relatively simple equipment that this takes. I just tried it for the first time this year. Gave great results, good consistent results. White grape juice, orange juice. This is the first time I've tried it with orange juice that had pulp. It worked well. Grapefruit juice, excellent. You can even have different students do different juices and rank them. Okay? Real good experiment. Fits into pretty much any kind of a chemistry class because it involves real stuff.